apparently I'm getting long-winded. My memory card filled up, so I'm not sure where the last video cut off. I think it was maybe fairly close to where I was because I heard a little beep about the time it decided it was full. But let's see, okay. To find the vertex of f of x equals y equals negative 3x squared plus 4x minus 9. The zeros are at x equals negative b plus or minus the square root of the discriminant, all that over 2a. The vertex is halfway between the zeros because of the symmetry of the quadratic function. It's symmetric about its axis of symmetry, and the vertex is on the axis of symmetry, so the zeros have to be at equal distances on either side of the axis of symmetry. Well, so halfway between the zeros, well, first of all, let's just look at the numerator. Halfway between negative b plus this square root and negative b minus this square root, well, as I demonstrated, and you probably already saw this, but halfway between my nose and an arm length on this side of my nose and my nose and an arm length on this side of my nose is what? It's my nose. So halfway between my nose plus an arm length and my nose minus an arm length is my nose. Similarly, halfway between negative b plus the square root of the discriminant and negative b minus the square root of the discriminant is what? Is negative b. That's my nose. Okay, so it follows that negative b over 2a is halfway between your zeros. Now, whether you completely understand that or not, you can see this expression sitting there smiling at you from within the quadratic formula, so learn to identify it if you don't understand why that's the coordinate of the zeros. It's not a separate thing you have to memorize in addition to the quadratic formula. It's just the appropriate part of the quadratic formula. Anyhow, okay, so negative b over 2a is halfway between your zeros, so it's the vertex. So the vertex is at x equals negative b over 2a. Plugging in b equals 4, and I plugged in negative 4 for b. So I had a mistake, okay. Yeah. Okay. It's negative of 4 over negative 3, which is plus 4/3. It's going to change my calculation a little bit down here. Okay, so that's the x-coordinate of the vertex. The y-coordinate, as we saw here by this example, when we were given the x-coordinate of the vertex, how did you find the y-coordinate? Well, you plugged it into the function, and we saw why that works. So review that if you're not sure why this works. Anyhow, this is going to be f of not negative 4/3, it's going to be positive 4/3. It's going to be negative 3 times 4/3 squared, and 4 times 4/3. Just plugging the 4/3 into this equation. Negative 3x squared is negative 3 times 4/3 squared. 4 times x is 4 times 4/3, and the negative 9 is still negative 9. Now, this changes a little bit in the solution because here we have negative 3 times 16/9. That's the same as it was before, because when we squared the negative 4/3, it was still 16/9. But 4 times a positive 4/3 is plus 16/3, and that's going to change this over here to plus 16/3. We still get negative 9, so the only thing that changes due to my sign error here is the sign of this term. Well, conveniently, the negative 16/3 and the 16/3 add up to 0, and we get, instead of what I wrote here, we get well, I'll write it out. It's negative 27/3. But of course, if we saw that this and this add up to 0, we didn't even really have to put the negative 9 over 3. Well, that then is negative 9. So that's equal to negative 9. If we want to plot our vertex, we come over to 4/3, which is just a little past 1. And we come down 9. So our parabola is going to look like that. And of course, since you have a negative in front of x squared, the parabola opens downward, so it's going to be here, and it's going to open downward, and it's going to be fairly narrow because of that -3. But that's another subject.